So alright guys, today's project I'm rather excited to talk about. It's not fully complete yet, but I'm going to talk about the progress with it and what I got done so far. Now with that said, if you haven't read the title of the video, today I'm going to be talking about these low-powered devices that I've been working on. If you're wondering why I've been putting effort into building these, well, I wanted to make my own little low-powered kinetic sculpture very similar to the ones you find in the dollar store, with nothing more than my 3D printer and just a handful of parts that I have lying around. Although as I dug into this rabbit hole, those little kinetic figurines you get from the dollar store turn out to be a lot more complex than you may think. In fact, they use a whole IC comprised of like 1,000 chips. That is not going to work for me, so what I ended up settling on was a simple astable multi-vibrator circuit and a 2-magnet design or a singular magnet design. What this means is if the cube here in this video stopped for whatever reason, most likely it would not auto start up again, although with some proper geometry hacks I could probably get this to go again on its own, but right now if I were to stop it, it would not start up again on its own without me spinning it. It's as basic of a circuit as you can get, and if you want to build your own, it's very easy. As you can see on screen, this is the circuit, and it's essentially just a modified version of an astable multi-vibrator circuit. Those are typically sold as LED blinker kits online. I'll leave a link down below in the description for one if you wish to just buy a astable multi-vibrator kit and assemble it and just change up a component here or there. Essentially, all you have to do to modify these circuits is replace the second LED with a 330 ohm resistor, and on the output where the second LED would be, you add your air coil. From here you could put the LED in reverse if you happen not to have any diodes lying around, or you could put a proper diode in there. I used the LED because I wanted to see the inductive kickback in action as the magnet passes over this coil, but my air coil is not quite large enough to do a high enough feedback or a kick to that LED to light it up each time it spins. And if you didn't know, yes, you can use an LED in reverse as a diode. It's not perfect and you'll waste some power, so I may remove this in the future as the design finalizes. But yeah, speaking of the design, if you want either of these designs, the second one's not really finished, but I'll provide it anyway if you want to work on it. The first design is pretty finished, so if you want to print it, all you do is you print it out, glue the box to the top piece, and then the lid snaps on, and the top piece also snaps on if you would rather snap it on, but I will provide a screw version as well. As you can see here, this top piece is held on with screws. The only problem is it interferes with the magnet, so I probably won't provide that model unless somebody really wants it. But overall, why did I do this again? Why did I make these low-powered devices just to be powered with some AA batteries? No, I'm going to power it with something different. So I thought about saltwater batteries at first, but then I was like, that's going to get messy, the water's going to spill, I'm going to need liquid-tight containers. It just looked like a problem all around. Plus the salt would end up dissipating to the bottom of the container, and then the effectiveness of the battery would go down drastically. Then I thought about using some kind of potato-like battery or lemon battery, but then again that lies the same problems as well. When I came to the idea of using dirt as the medium for my galvanic battery, I was just walking around outside and happened to stumble upon some rusted nails, and that got me thinking, what if I just use soil for the electrolytic medium instead? Let alone and behold some research online, I found a few papers, and yes, you can actually wire enough of these up in series to light up an LED. I barely was able to with these 3D printed cells, and yes, these are liquid tight 3D printed cells. So there was some promise with this miniature cell that I was working on. However, the current output drops drastically and it sucks over time, so I decided to ditch this method, and I stumbled upon a video online of somebody else just by accident when I was looking up this problem, and it turns out somebody else had the same idea and has built very low powered devices powered with dirt as well. So I'll link their video in the description. I forget the channel name, but I watched it and it was very insightful, so I came to the conclusion that the small cells that I've been using, they could probably work if I do enough series and parallel connections, but at that point it involves intricacy and things could fail, so I decided to just scale up the cells. I'm going to be using like soup cans, and I'm going to try to get away with like 4 of them. And after that, I'm going to put some terrarium plants nearby in them and stuff and seal the whole thing shut. If you're wondering why I want to seal the whole dirt battery shut, it's to create a miniature terrarium, because if this thing is going to be on top of it, I want it to look nice, I want it to not look too out of place, and I want the cells to maintain their level of humidity or moisture. So I thought if I make it a terrarium, place it, I'll never have to touch it again because the plants will self-cycle the water around and keep the thing pretty much humid. That's my main goal. It's not built yet, but when it's built, I'll be sure to update you guys on a second part for this video. But for the time being, guys, that is it. There ain't much more to talk about because I haven't done much more with this. But I guess if you want the original 3D printed cell, these ones here, the testing ones where I put it in a cotton candy container, this actually worked really well. It's still reading a volt 30 as intended, and the humidity in the container indeed is actually working. So these things have been self-sustaining themselves rather nicely. So I'll link that model down below in the description if you wish to take it a step further, work with it, or perhaps just use it as a science fair experiment or something. Oh yeah, I kind of forgot, the bearing mechanism for the spinner is just a screw and a needle. I did put some WD-40 on the end just in case, also to help it spin a little more smoothly. In fact, this thing spins so freely that if I took a magnet off, got the screws out of the top so that they wouldn't draw the magnet to it, this could effectively be used like a compass. And to prove the fact that this makeshift bearing actually works out pretty great, this thing has been running for about 4 to 5 days now. Pretty much non-stop, without issues. But with that said, I'm going to leave today's video off here now. DTPK signing off. Peace. So believe it or not, the lasso causes this specific glitch to happen, so the only requirement
that will leave your guests stunned. You can buy yours at the link on screen now.